Okay, so here we have a question uh, for the following circuit. Find the range of values of V2. The range of values of V2 that will keep the op-amp operating in its linear region. So that's the question. We need to find the range of values of V2 such that this op-amp remains in the linear region. And it's given that V plus is 20 volts. So the positive voltage is 20 volts and the negative voltage is minus 20 volts. And we know that V1 is given to be 10 volts. Note that the output voltage of the op-amp should remain within, even this hint is given that this voltage VO cannot be outside this range for this op-amp to operate in the linear region. So now we have to come up with an equation that that relates VO with V2. In this fashion, we will put VO equal to plus 20 in that equation and find the value of V2. And then we will put VO equal to minus 20 in that equation and find that value of V2. So V2 would be would vary between those two values. So that is how you attempt a problem. You first read it, you understand it, then you devise a mechanism what is to be done. Once you are clear what you are looking at and what you want to do, then start something. Don't just write a few things here and there and expect that some marks would be given to you in real exams. So we know this is 0 volts, this must be a 10 volts, and we know there will be no current flowing into this because of ideal op-amp characteristics, no current. So the voltage here would be 0, so this 10 volt will appear here as well, and this would be also at 10 volts. So we have 10 volt here, 10 volt here, 10 volt here, so no current flowing in here as well. So no current flowing because here on this side it is 10 volts, on this side is 10 volts. So what's the voltage across it is also 0 volts. No current is going to flow here. No current flowing in here, no current flowing in here. So we have 10 volts here. Okay. So but we don't know what the voltage is here. It's not grounded. It's not 0. So V2 is not 10. Uh, okay. This is something that actually I have not taught in here. Um, This is called a delta configuration, a delta configuration of resistors. We cannot simplify these based on the series parallel concepts. So you can see these two. None of these pair are basically in series or parallel. These are not in series because this is a branch carrying current, uh, and these are not in parallel as well. So how to solve this? Basically, we use if we want to resolve these, we can convert this delta into a Y configuration. But here, let me skip that for a moment. Let us label this as V1. So V1 was already there. Let us label it as V2. This is 0 volts. VO, this is V1. So let us come up with some equations. The equations are, remember, never write an equation for KCL for the output terminal of an op-amp. Why? Because it is not that no current will be going in there or coming out of here, and we just write these two branches, and often students ignore this branch as well, but there will be some current here as well. So it's not like writing KCL here. We write for this, we write for this, we forget this, or we don't care for this because of the ideal op-amp characteristics. Usually students tend to mix these things up, so it's recommended to be very careful. So let us write KCL equation for V2. V2 minus 0 over 4 plus V2 minus VO over 4, and we cannot write equation for this. Oh, we have ignored this thing that if this is V2, we cannot label it as V2 as well. So let us label it as v3. So now we can write v3 minus 0 over 4 plus v3 minus vo over 4. But then we cannot write equation for this branch as well, because there is no resistor in here. So we cannot actually write this equation. So this is not a good mechanism. So how to come up with an expression for this is, oh, okay. So we have this 10 volts, and this is higher potential, then the lower potential will be 10 minus V2. So let us not use another label. This V3 is actually equal to 10 minus V2. Okay. And what we know otherwise, this current is 0. So let us say this is I2, it is 0. No current will be flowing in here. Let us call it I negative, this is 0. So actually this current is 0 as well. Let us label it as, let us call this I2, let us call this I3, this is 0 as well. So no current coming in here. This current I3 is 0. How much will this current be? This will be V3 over 4. How much will this current be? This current will be V3 minus VO over 4. So actually we can write this, because we know 0 current is coming from here. We can write V3 minus 0 over 4, this current, this plus this current. All the outward currents, sum of all the outward currents would be equal to 0, because there is no current flowing in here. So we are actually not concerned in writing KCL here. We can ignore this branch as well. So this is an equation with two unknowns. We need another equation, and for this equation we can apply KCL here as well. So this is at 0 volt, this is at 0 volt, this is actually ground. We have this current coming in here. We don't know what the current going here, but we know for sure that this current will be 0. So no current going, this current would be 0. So whatever the current would be flowing here, this current would be flowing in the opposite direction. So this current going here, all the current would go here. And all this current going here must be coming from here. So if we apply KCL here, so this is one node, this current is 0, so only two branches carrying current. So we can write 0 minus V3 over 4, this current, plus 0 minus VO over 4, this current, is equal to 0. So we can actually more easily solve this, and we can find that VO is actually equal to minus V3. VO, we can multiply by 4 throughout. VO goes to this side. VO is equal to V3. VO is equal to 10 minus V2. So we have found that expression actually, the relationship between VO and V3. Oh, we could have done that from here as well. but we are going to get a different expression from here. This equation says, but this equation says VO is going to be equal to 2V3. This is strange. What's wrong here? Either something is not adding up. Actually, I cannot find anything that we have not done adequately. So if one equation says VO is equal to minus V3 and the other equation says VO is equal to 2V3, what values of VO and V3 can satisfy both these equations? Obviously, VO and V3 are both 0. So in this configuration, V3 is 0 and VO is 0 as well. So we see VO does not depend on V2. This boils down to whatever value of is the value of V2, the opamp operates in linear region. I am sure that by randomly making a question, these things often happen, that the solution you expect is not what you get, but it's just is a good learning.